Let's look at the conservation of mechanical energy. Now, before we know the conservation of mechanical energy, let's delve on what is mechanical energy. This is a revision from grade 10. Mechanical energy is the sum of kinetic energy and gravitational potential energy. So here's it. It's ME, which is mechanical energy, is the sum of kinetic energy and gravitational potential energy. Just a little bit of reminder. What is the gravitational potential energy? Gravitational potential energy, it's an energy due to height. Now, if you have, this is a height, if you have an object in a height there, that means this object possesses the gravitational potential energy because it has a height. So you take its mass and you multiply by the gravitational acceleration times by its height. So it will have the gravitational potential energy. But when an object it's there on the ground, if you take ground as a reference, and there's no height here, the height is zero, therefore the gravitational potential energy will be zero. So gravitational potential energy, it's an energy due to height. Now, let's look at the kinetic energy. What is kinetic energy? It's a reminder as well. Kinetic energy, it's an energy due to movement. Energy due to movement. So if an object has a kinetic energy, okay, let's say if an object has a velocity which is moving, that means it has a kinetic energy. So if this object here, it's at rest, that means its velocity is zero and therefore its kinetic energy will be zero. The velocity and the kinetic energy are directly proportional. Greater velocity, greater kinetic energy. Even the height is directly proportional to the gravitational potential energy. Greater height, greater gravitational potential energy. So if an object is at rest, as I've mentioned, okay, if an object its velocity is not equal to zero, that means the kinetic energy is not going to be equal to zero as well. Now, both these are energies, they are measured in joules. So even the mechanical energy, you add the two and they are in joules. It's an energy. Now, let's look at the closed system. A system is closed when the net external forces acting on object is zero. Therefore, no frictional force of applied forces or applied force present. Guys, if the system is closed, that means that the non-conservative forces are not there. Look at my previous video when I talk about the non-conservative force. So the external forces and non-conservative forces are the same thing. So the system is closed if there are no non-conservative forces. If the system is open when there's a non-conservative force, even if it's one, it doesn't have to be all of them. Now let's look at the principle of conservation of mechanical energy. The total mechanical energy in a closed system remains constant. What do we mean the system is closed? Is when the net external force is equal to zero. For example, here we take this one as a closed system because this path is frictionless. So if it's frictionless and there's no force applied there, that means it's a closed system. So, what do we mean by the total mechanical energy in a system remains constant? We mean by the mechanical energy here everywhere in this path up until to point B, the mechanical energy is constant. If you can calculate the mechanical energy here, it will be equal to the mechanical energy there at the bottom. The mechanical energy here, it will be equal to the mechanical energy here. Mechanical energy here will be equal to the mechanical energy there, and so forth. Guys, the equation for the mechanical energy, guys, here, it's the mechanical energy at A is equal to the mechanical energy at B. This is the conservation of mechanical energy. So it's equal. Mechanical energy there equal to the mechanical energy there. There is it. And then we know what is the mechanical energy is the sum of gravitational potential energy and kinetic energy. Gravitational potential energy and kinetic energy of the at the bottom. Guys, another thing that I want to show you. Let's say this object is moving down. So its velocity is not going to be equal to zero because it's moving, right? Then therefore that means the kinetic energy is not going to be equal to zero because it has a height. It's in the height is not equal to zero, and the gravitational potential energy is not going to be equal to zero. So the mechanical energy here, it's going to be equal to EK plus EP there at point A, right? And then it goes down the object. Here at the ground, the height is what? Is zero. That means the gravitational potential energy is zero. And then when it gets here, it gets with a greater speed, because as an object it goes down, its speed increases. So there's a velocity there. There's a velocity there, is not equal to zero, and the kinetic energy is not going to be equal to zero. So therefore at B, the mechanical energy there, it will be the sum of what? Of kinetic energy and gravitational potential energy. But the gravitational potential energy is going to be what? Zero. The kinetic energy is going to be the value, whatever value that is it. Guys, this formula, it's very important. It's very important. The formula for kinetic energy, it's half mv squared. And so that's the formula, guys. Another thing that is important about the conservation of mechanical energy formula, this one, it only works when the system is closed. You can't use this formula, guys, when there's a friction, there's a force applied, there's a tension, the brakes are applied, there's the force of an engine. You can't use this formula.